Okay, so we are back with example number 2 for verifying trigonometric identities. Here we have tan theta plus cosine theta all over sine theta equals secant theta plus cotan theta. So again, we're trying to show that the left-hand side is equal to the right-hand side. In this case, I'm going to start off by working on the left-hand side because typically dealing with fractions is more challenging than dealing with this sum over here. So we're going to play around with this side instead of the right-hand side. So one of the techniques that you might try when you're trying to verify an identity, especially one that contains a fraction, is to break up this fraction into a sum of two fractions. So that would look like this: tan theta over sine theta plus cosine theta over sine theta. And again, that's going to equal secant theta plus cotan theta. That's what we're trying to show. Now, the reason why I did that initial step is because I recognize that cosine theta over sine theta is cotan theta. So I thought that that might be a good place to start. So that's the reason why I did that. So again, I can immediately make that switch. Cosine theta over sine theta is equal to cotan theta. Now we need to deal with tan theta over sine theta. We're trying to turn this into secant theta. Well, secant theta we know is 1 over cosine. So I think what I'm going to try to do here is rewrite tan theta in terms of sines and cosines and see what happens. So let's do that. So tan theta is sine theta over cosine theta. And now that's all going to be over sine theta. So again, in the end, this expression should equal secant theta plus cotan theta. Now again, we have the cotan theta, so we want to try to mess around with this fraction here to see if that equals secant theta. Well, if you notice, sine theta over cosine theta is in the numerator, and then sine theta is in the denominator. So to fix this, what I'm going to do is I'm going to multiply the numerator, sine theta over cosine theta, by the reciprocal of the denominator, and that's going to look like this: 1 over sine theta times sine theta over cosine theta. And now when we multiply this out, these sine thetas will divide out, and we're going to be left with 1 over cosine theta. So now we have 1 over cosine theta plus cotan theta, and that's supposed to equal secant theta plus cotan theta. And as we had mentioned before, 1 over cosine theta is equal to secant theta, so we'll make that final replacement. Secant theta plus cotan theta equals secant theta plus cotan theta. There we have it. Another